Hello everyone. So today we'll be discussing about number system operation. This discussion will be divided into two parts. For part 1, we will be discussing about the addition of each number system, and for the second part, we will be discussing about the subtraction of each number system. So for the first part, which is addition, we will first discuss about the addition of binary numbers. This is a tabular representation of or the sums of specific combination of binary numbers when you add them. So 0 plus 0, you'll get 0. 1 plus 0, that will be 1. 1 plus 1, that will be 1, 0. And 1 plus 1 plus 1, that will be 1, 1. So to further understand the addition of binary numbers, here are some examples. For the first one, we will just be adding a whole binary number without the fractional part. 1001101 plus 10111. So we will start on the rightmost side. So 1 plus 1, that will be 0. Carry 1. And then we will add 1 plus 1, that will be 0 again. Carry 1. 1 plus 1 plus 1, that will be 1. Carry 1. And 1 plus 1, that will be 0. Carry 1. 1 plus 1 plus 1 will be 1. Carry 1. We'll bring down 1 since 1 plus 0 is 1. Then we'll bring down the rest of the binary number. So the answer for the first example is 10110100. Now for the second example, we have 1011101.01 plus 11011.01. As usual, we are going to start on the rightmost side. So 1 plus 1 will be 0, carry 1. 1 plus 0 plus 0 will still be 1, so we'll have 1 here. Point 1 plus 1 will be 0, carry 1. 1 plus 1 will be 0, carry 1. 1 plus 1 will be 0, carry 1. 1 plus 1 plus 1 will be 1, carry 1. 1 plus 1 plus 1 will be 1, carry 1. 1 plus 0 is 1, and we'll just bring down the last bit right here. So the answer for this example is 1111000010 binary. So for the next topic, we will be adding decimal numbers. For the first example, we have 749 plus 382. The first thing you have to do in adding decimal numbers is add each digit. We have 9 plus 2 is 11, 8 plus 4 is 12, 7 plus 3 is 10. After adding each digit, you have to subtract the base of a decimal number, which is 10, if the sum of the two numbers is greater than the maximum number we can use in representing a decimal number. And take note, if you perform a subtraction, you have to carry or add 1 to the next sum. So in this case, 11, that is greater than 9, so we'll have to subtract 10 from it, and the answer will be 1. Since we perform a subtraction, we will add 1 to the next sum, which is 12. So we have 13, and 13 is still greater than 9. So 13 minus 10, that will be 3. And we perform a subtraction, so we'll add 1 to the next sum, which is 10. So it will be 11 minus 10, and the answer will be 1. Since we performed a subtraction, we will carry over 1. We'll just bring it down. So the final answer will be 1131. For the next example, we will just do the same thing. So 7 plus 7 is 14, 3 plus 7 is 10, 6 plus 9 is 15, 7 plus 4 is 11, and 8 plus 0, that will be 8. And since most of the numbers are greater than 9, we will have to perform subtraction. So 14 minus 10 is 4, carry 1. 11 minus 10 is equals to 1, carry 1. 16 minus 10, that will be 6, carry 1. 12 minus 10 is 2, carry 1. Since 9 is the maximum number you can use to represent a decimal number, there is no need to perform a subtraction, so we'll just bring down 9. So when you add 876.37 plus 49.77, you'll have a sum of 926.14. For the next topic, we'll be adding octal numbers. So for the first example, we have 373 octal plus 26 octal. The process is the same as how we add a decimal number. So first, we'll add the digits. 3 plus 6 is 9, 7 plus 2 is 9, 3 plus 0 is 3. Since the largest possible number we can use in an octal number system is 7, we'll have to subtract. So 9 minus 8, that will be 1. Since we performed a subtraction, we'll have to carry 1 to the next sum. We now have 10. 10 minus 8 is 2. Since we perform a subtraction, we will have to carry 1. We'll have 4. 4 is not greater than 7, so we'll just have to bring it down, and the answer for this is 421 octal. For the next example, we have 765.23 plus 12.77. Both are octal numbers. So the same process as we did for the first example. 7 plus 3 is 10. 2 plus 7 is 9. 5 plus 2 is 7. 6 plus 1 is 7. 7 plus 0 is still 7. Since 10 is greater than 7, we will have to subtract. So 10 minus 8 is 2, carry 1. 10 minus 8 is still 2, carry 1. 8 minus 8 is 0, carry 1. 8 minus 8 is 0, carry 1. 8 minus 8 is still 0, so we have to carry 1. And since there are no more numbers to subtract it from, and it is not greater than 7, we'll just have to bring down 1. So the final answer for this example is 1000.22 octal. For the last topic, we will be adding hexadecimal numbers. For the first example, we have 3AB hexadecimal plus BF hexadecimal. First thing we have to do is to add the digits. So B plus F is 26, A plus B is 21, 3 plus 0 is 3. Since some of these sum are greater than the highest possible number we can use in a hexadecimal system, which is 15, we will have to subtract the base of a hexadecimal system, which is 16, from the sums. So first, we have 26 minus 16, that is 10. We'll carry 1 since we performed the subtraction. Now we have 22 minus 16, that will be, the answer is 6. And we'll carry 1 to the next sum since we performed the subtraction. So 3 plus 1 is 4. 4 is not greater than 15, so we'll just bring it down. So the answer for the first example is 46A hexadecimal. Now for the next example, we have 2DF.BC hexadecimal plus 39.57 hexadecimal. We will do the same thing as we did on the first example. So first add the digits. C plus 7, 19, B plus 5, 16, F plus 9, 24, D plus 3 is 16, and 2 plus 0 is 2. We will be subtracting 16 from the sums that are greater than 15. So first sum is 19. 19 minus 16, that is 3. Carry 1 since we perform the subtraction. 16 plus 1 is 17. 17 minus 16 is 1. So carry 1 again. 25 minus 16, that is 9. Carry 1. 17 minus 16 is 1. Carry 1. 2 plus 1 is 3. Since 3 is not greater than 15, we'll just have to bring it down. So the final answer for this example is 319.13 hexadecimal. For the second part, we'll be discussing the subtraction of binary decimal, octal, and hexadecimal. For the first topic, we will be subtracting binary numbers. So for the first example, we have 11011 binary minus 1101 binary. Now, all you have to do is subtract each digit from one another, starting from right to left. So, 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 1, that is cannot be, so we'll have to borrow from the next term. And the next term is 1. Usually in decimal numbers, we'll borrow 10, right? Since we are subtracting binary numbers, we are going to borrow 2. So we'll have 2. 2 minus 1, that will be 1. Since it's 0 minus 1 again, we'll have to borrow to the next term. So we'll have 2 again. 2 minus 1 will be 1, and we'll just bring down 0. Now, the answer for this example is 01110 binary. For the next example, we'll just do the same thing. 111100.0110 binary minus 11101.1001 binary. We'll have to subtract each digit starting from the rightmost side to the left. So the answer for this example is 01110.1101 binary. For the next topic, we will be subtracting decimal numbers. So for the first example, we have 29 minus 18. So we will subtract each digit from one another, starting from right to left. 9 minus 8, that is 1. 2 minus 1 is 1. So the answer for this example is 11. For the next example, we will be subtracting 36.582 from 45.221. So we cannot subtract 1 from 2, so we'll borrow 10 from the next term. So that will be 11. 11 minus 2 is 9. Since we cannot subtract 1 from 8, we will borrow from the next term. So 11 minus 8 will be 3. Now, we cannot still subtract 1 from 5, so we'll borrow again. We have 11 minus 5, that is 6. We cannot subtract 4 from 6, so we'll borrow again. 14 minus 6 is 8. And for the last digit, 3 minus 3 is 0. So the answer for this example is 8.639. For the next topic, we will be subtracting octal numbers. For the first example, we have 6317 octal minus 456 octal. As usual, we will subtract each digit from one another, starting from right to left. So 7 minus 6, that is 1. We cannot subtract 1 from 5, so we'll borrow 8 from the next digit. So we have 9 now. 9 minus 5, that is 4. Since we cannot subtract 2 from 4, we will borrow 8 from the next digit. So 10 minus 4, that is 6, and 5 minus 0 is 0. So the final answer for this example is 5641 octal. For the next example, we'll just do the same thing. 5442.361 octal minus 3751.3 270 octal. So we'll do the same process as we did on the first example. 1 minus 0 is 1. Since we cannot subtract 6 from 7, we'll borrow 8 from the next digit. So we have 14 now. 14 minus 7 is 7. 2 minus 2 is 0. 2 minus 1 is 1. We cannot subtract 4 to 5. So we'll borrow 8. Now we have 12. 12 minus 5 is 7. We cannot subtract 3 to 7. So we'll borrow 8 from the next digit. Now we have 11. 11 minus 7 is 4. 4 minus 3 is 1. So the answer for this example is 1471.071 octal. For the last topic of this part, we will be subtracting hexadecimal numbers. For the first example, we have 98DF67 hexadecimal minus 6FC439 hexadecimal. We'll be subtracting each digit from one another, starting from the rightmost part to the left. We cannot subtract 7 to 9, so we'll borrow 16 from the next digit. So we'll have 23 now, minus 9, that is 14. Now 6. Now 5 minus 3, that is 2. F minus 4 is 11. D minus C is 1. We cannot subtract 8 to F, so we'll borrow 16 from the next digit. Now we have 24. 24 minus F is 9. And lastly, 8 minus 6 is 2. Now, right now, all we have to do is properly represent each digit. So 14, its hexadecimal equivalent is E. 2 is still 2 in hexadecimal. 11 is B in hexadecimal. 1 is still 1. 9 is still 9. 2 is still 2. So the answer for this example is 291B2E hexadecimal. Now, moving on to the next example, we have 67831.3D hexadecimal minus 21BC0.2E hexadecimal. We'll do the same thing as we did on the previous example. D minus E. We cannot subtract D to E, so we will borrow 16 from the next digit. Now we have 29. 29 minus E, that's 15. 2 minus 2 is 0. 1 minus 0 is 1. We cannot subtract 3 to C, so we'll borrow 16 from the next digit. Now we have 19. 19 minus C is 7. Since we cannot subtract 9 to B, we'll borrow 16 from the next digit. So now we have 25. 25 minus B is 14. 6 minus 1 is 5, and 6 minus 2 is 4. Now, all we have to do is properly represent each sum from their respective hexadecimal equivalent. So, 15, that is F in hexadecimal. 0 is still 0. 1 is still 1. 7 is still 7. 14 in hexadecimal is E. 5 is still 5. 4 is still 4. So, the answer for this example is 45E71.0F hexadecimal. Now for a quick summary, for the addition part, all you have to do is first add the digits, then subtract the base of that digit if the sum is greater than the maximum possible number you can use to represent that number system. And make sure to add 1 to the next sum if you're going to perform a subtraction from the previous sum. Now, for the subtraction part, all you have to remember is that if you cannot subtract the minuend from the subtrahend, you have to borrow from the next digit. And the number you will be borrowing from the next digit will depend on the number system you are subtract. For binary numbers, you can borrow 2. For decimal numbers, you can borrow 10. For octal numbers, you can borrow 8. And for hexadecimal numbers, you can borrow 16. So that is all. If you have questions, please don't hesitate to ask them on the comment section below for it to be addressed properly. If some of the examples are quite confusing, please do leave a comment so we can clarify things out. Thank you.